So basically, we're recording now, and then what I'm going to do is I'm going to try to share my screen with you so we can go through the setup of the course in Canvas, and then we'll start reviewing some of those topics from College Algebra that are essential to being successful in the course, okay? And if you have questions at any time, I'd encourage you to please type them in the chat, okay? I'll monitor the chat as we go along, okay, to make sure I'm not missing anybody's questions. Okay, so sharing content, and let's see what it is I can share here. Chrome, share. All right. So I'm sharing Chrome, and hopefully we can see my class. And again, of course, I can't see the tabs at the top. Let's see. All right. Can everybody see my screen here? Okay, I'm sharing the Canvas course with everybody. So hopefully everybody can see that. Okay. If you're having trouble seeing that, just let me know. Okay. And what I'm showing you is the Start Here module. Okay, the way you want to navigate our course is you want to start in modules, which is this link right over here. And you can see there's a Start Here module and it says complete by August 28th. Okay, that's this Friday. This is kind of how I'm making sure everybody is attending the course. Normally, I would take attendance on the first day. That's virtually impossible in this live online environment because people drop in and out of the live online session. So what I need you to do is I need you to complete this whole module by August 28th, okay? There's some expectations here, okay? It'll describe pretty much how a live online class is set up. There's how to prepare for the lecture. Okay, there's an introduction that has a little video by me, how to join WebEx from Canvas. There's a little pre-test to kind of make sure that you have enough algebra background to be successful in the course. Don't worry about it. It's not high stakes. It's more informational for me. Here's an online learning survey. Since our class is a live online format, there's more of an online flavor to this than there would be if we were meeting in a face-to-face environment. So this is kind of my guesstimate on how comfortable you are in this environment, okay? There's a 3-question syllabus quiz, okay, that just pretty much asks you, did you read the syllabus? The syllabus is over here, okay? And then there's some instructions on how to enter answers in more. You might have realized, as I said in my announcements, we're not buying any books. We're not buying any access codes. This is a no extra course cost class. So all you had to pay for was tuition, and all of the materials that you need for the course are here in Canvas. Okay, we're using MORE, which is Maricopa Open Educational Resources for Math, and that's a free homework system. It's a lot like my math lab if you've had experience with that. Okay, but this will walk you through how to enter answers in there. And the last thing you have to do, okay, is participate in this discussion board by this Friday. Okay, you want to post a picture if you can, and answer some of the discussion board questions just so we can start building community. It's going to be a little harder to collaborate in this environment, but if you guys all stay engaged, we can do that, okay? So let me pause at this point and ask, does anybody have any questions about the Start Here module? Okay, just type in the chat. Okay, any questions at all about Start Here? Okay, so far so good. Okay, you'll notice if you look at the syllabus, There is a schedule at the back of the syllabus. I'll see if I can get over there so you can see it. You can download a copy here, and then here's everything laid out. Okay, it's laid out by date. And you can kind of see that we're going to be doing 2 sections this week. So we'll do section 1.1 and we'll do section 1.2 this week. Okay, we'll hopefully get through 1.1 today and then 1.2 on Wednesday. But let's go back to modules so you can see exactly how that's laid out. Okay, if I have to deviate from the schedule, I will let you know. Okay, each module, now here's the one that's due, every module's homework or assignments are due by Sunday at the end of that week. So the next Sunday coming up is August 30th. Okay, and that's when these assignments are due. Okay, this is where I'm going to post the links to our videos. Okay, at week 1 live online sessions. Okay, you can see session 1. I'm showing you what we're doing. Okay, the meeting link is not relevant because you're logging in from Canvas, so I will get rid of that. But I will put a YouTube link here that will allow you to play back the recording in YouTube. Okay, so there'll be one of these for each one of the weekly modules. Okay, and then you can see you've got function objectives, okay, and that's going to tell you what the point of this section is, okay, and again, if we click on this, it'll tell you what we're learning, and you can see we're defining a function, evaluating functions, we're looking at 9 toolkit functions or families of functions. We're going to go over interval notation a bit, and we're going to talk a little bit about domain and range. Again, this should all be familiar to most of you, but we're just kind of making sure we're all at the baseline of what we need to know to get started. Okay, here are videos that you can watch on these topics. Again, it's supplementary to the textbook. This is your textbook and it's broken into sections. It's an online open source textbook. So you can actually go and read about the topics. Okay. I actually have one section of that open over here. Okay. And if you take a look, okay, here's the learning activities. All right. So this is the videos, readings, and objectives. Okay. This is optional. So if you want to review any material, you can dive in there. These are the assignments that will be due on August 30th, okay? This function review in the homework and the exponential and logarithmic functions, okay? You don't need to log into any other homework management system. You can get into these directly by just clicking on the links, okay? Hopefully that will open for me without a problem. And again, you can get into this like this, all right? All right, so basically it's due on the 30th. What I've done for homework, okay, they have due dates, all right, but what you have given to you are 10 what are called late passes. Okay, so if you let an assignment expire, like go past the due date, you get 10 late passes that will extend the due date by 3 days, okay, and you can stack them on an assignment, but you only get 10 of them for the entire semester. So it's up to you to use the late passes to manage your time. All right. The idea is I wanted to give you some flexibility with due dates, and this homework management system allows the use of late passes. So if you see your assignment become past due, you should see a link for use late pass come up, and you'll be able to use one of your late passes to finish it. Okay. So again, what I would encourage you to do is to complete the assignments, because anything incomplete, okay, if you never open it and you never try it, that assignment turns to a 0 at the end of the semester. Okay, if you partially complete an assignment, then that would become your score on the assignment if you let the due date lapse. Okay, everybody understand how late passes work? Okay, late passes, okay. Anybody questions about how you're accessing assignments? Okay, I'm assuming everybody is familiar with discussion boards in Canvas, so putting things on discussion boards is not Not going to be a struggle. Okay. So I'm just backing back up here. And again, sometimes I'm going to scroll down to week 2. You'll notice that week 2 has a discussion board as well as the homework. And sometimes I'll put in supplementary materials. What these are optional notes that I may use in class. And I sometimes, because calculus is the math of change, I like to put in interactive applets. Okay, so this is a link to an app that will actually let you play with the concepts. Okay, so this is pretty much how the course is laid out. I've tried to lay out every week in the same format, right? So again, if you have any questions at all about any of the assignments, the layout or whatever, feel free to email me in Canvas anytime. And, I guarantee you I will turn around those questions within a 6-hour period. If you email me late, like at around 11 or 12 at night, I'll get to you like at 5 the next morning. Okay, but I really do try to turn around questions as quickly as I can. Oh, and one other interesting thing, let's see if I can bring up that more assignment again. Function review. I'm going to try teacher preview. Let's see if that works. I want to show you what it looks like. And again, here's questions. And if I scroll down to the bottom, do you see that each question has videos attached to them? So there's question help. Okay. And this link here should be on every homework assignment. It says message instructor. If you try a problem 3 times and you keep getting it wrong, or if you are stuck on it for 15 minutes and you can't make progress, hit this link, okay? And it will send me an email with your problem in it, okay? The reason I need the email from you is because everybody gets different numbers on the problem. That's the way this more homework management system works. It will generate different numbers for each student. So in order for me to see the numbers you're working with, you need to message me, okay? So is everybody okay with the message instructor on the homework?
Here.
Everybody good with that? Anybody, any questions about that? Okay, some of you I'm sure are familiar with more, but I know some of you, this is the first time you'll be using it. It's pretty robust, it's pretty simple, and best of all, it's free. Okay, and Maricopa encourages faculty to use this for our math classes. Okay, so I'm going to back out and ask, does anybody have any other questions about the Canvas class? Okay, so questions about Canvas? Okay, anybody have questions about how it's laid out? Questions about anything else? Okay. All right. Okay, I'm going to roll you down to week 4 over here just to show you that we will have some exams in the class. Okay, yeah, don't worry about it, Jennifer. I'm recording, so you'll be able to look at the recording later if you think you missed anything. Okay, so basically, if you look at week 4 here, we're going to be doing a practice. Okay, we'll practice for the exam. We'll go over practice problems, and we'll use the 2 sessions to answer any questions you have on what we've covered up to that point. But this assignment is an online exam, okay? And you guys will do it on your own, okay? We're not going to log in, and I'm not going to be sitting there watching you for 2 hours take an exam, okay? You're going to be doing this on your own.
Period.
And then if you email me your work, I'll be able to give you partial credit on the exam if you've got a problem partly correct, okay? So that's how we're going to handle exams. All right, everybody good with that? So I think we have 3 unit like chapter exams and a final exam. Okay? So let me stop and say, everybody okay on exams, with exams? Everybody all right with how that works? So again, you can see all of this stuff is in Canvas. You don't have to go anywhere else for the information. So hopefully that makes it easy to manage. Okay, and particularly in this live online environment, which is, I know, not optimal as far as learning. Okay, but I would encourage you, if you've got any questions at all, make sure you reach out right away and ask. I'm more than happy to answer questions. I'm going to scroll all the way down to the bottom of modules, and you can see we've got our final exam. Okay, and then here are links to the textbooks, the textbook that I'm using in this class. This is also an open source. It's a Creative Commons licensed textbook. That means it's copyrighted. The author has decided to share it with the world for free. Okay, and those are the pieces of reading that are excerpted throughout the module. So here's the book altogether, if you prefer to look at it like that. Okay, but I have put the pieces you need to read in each of the relevant modules. This is kind of a general student information and resources section that should be in each one of your Canvas classes. Okay, it kind of has links to things that are just important on campus at this time, like technology and software, fields of interest, services, how do you use Canvas, okay, being a successful learner. This is Respondus. We are not going to be using Respondus, but if your other classes use it, there's information here. And Kurzweil, if you know you have a documented disability, I would encourage you to contact the Disability and Resources Services Office, and they may provide you with a license for Kurzweil software. Okay, so that's what that is down there. There's a lot of information in this course, but most of it is optional. I tried to give you more information than not enough. Okay, because we've all been in those classes that are kind of bare bones and it's not really clear what it is you're supposed to do next. Okay, so let me pause at this point and ask any questions. Any questions? And again, type in the chat. Okay, getting a bunch of no's. Okay, and if you're not comfortable asking in the chat, you're more than welcome to email me privately. Okay, so I'm assuming so far so good. Excellent. Okay, so what I thought I would try to do with you first is review a little bit about functions. So again, I've kind of opened the first chapter of our textbook over here, and it goes through what is a function. Okay, it's a relationship between an input quantity and an output quantity. Okay, you might not have heard those terms before, but maybe you heard independent variable, dependent variable. But what makes it a function is each input value gives you a unique input. You never have the situation where if you put a 2 into your function as input, sometimes you'll get a 4 and other times you'll get a 6. Okay, since we use functions to predict the output, we use them for modeling real world situations. A function that behaved like that gave you one output one time, another time, okay, that would not be very useful. Okay, so again, basically we want to say a given input gives you a predictable, uniquely defined output. That's how we tell. Okay, so what I'd like to do now is I am going to try to share my tablet with you. Hopefully we can see that. We go back to my sharing screen. Okay, and see web browser, share content. Okay. I am going to be using an app on my iPad, and hopefully you guys will be able to see it. So let me just get that set up. Okay, So where's Mary? Let's share that. So can everybody see this practice, relations and functions? Yes. Okay. I thought I saw a question go by there from Olivier. Olivier, we don't know whether or not we're ever going to meet in person yet. Currently, the classes for student safety are set up to be live online like this. Okay. I haven't been given any date that says, after this date, we'll go back to in-person classes. And I think what the college is trying to do is to make sure everybody stays safe. Okay. Infection rates are still pretty high in our state, and I think they would rather be safe than sorry. Okay, so that's the answer to the question. The question that went through the chat was, are we ever going to meet in person? And it's like, I really don't know the answer to that. Okay. But at this point, I would say there are no plans to do that anytime soon. Okay. So what I'm going to do here is I am going to, I'm going to basically move. Okay, can everybody see the screen? Okay, it should look like a bunch of diagrams and graphs and okay. So basically, if you take a look at it, all right, we can see that we have a relation here that's showing this circle on the left are our input values, okay, and the circle on the right, or the ellipse on the right, are the output values. So basically, this function takes -1 and maps it to -2. Okay, so my input value would be x, and my output value would be y. So if I were to draw this on the graph, I would draw a right here at -1, 2. Okay, the second point, okay, there's a 1, and sometimes it gives me -1, and sometimes it gives me 0. Okay, so basically, here's 1. Sometimes it gives me -1, and sometimes it gives me 0. What do you think about that? Is that a function? Anybody have any thoughts about that? Okay, Charlie's saying no. Okay, anybody agree? Okay, is this a function? Okay, remember we said before, what makes it a function is every input gives you a unique output. Jasmine's saying, no, wait, 2 dots on the same vertical line. Okay, so this isn't a function. Okay, why is it not a function? Because you can see it fails the vertical line test. See that right there? What that means is sometimes the input 1 will give you -1, and sometimes it gives you a 0. Okay? And basically, that makes it pretty useless for prediction. All right? So it's not a function. Right? Again, if we were to draw the rest of the ordered pairs, 2 will give us a 2. And 3 will also give us a 2, but that's okay. Right? Because again, we don't have the situation where sometimes 2 gives us a 2 and sometimes it gives us something else. That's perfectly okay. Okay. Does everybody understand this example? Everybody good with it? Okay. All right. Again, it's kind of tricky. All right. I wanted to do a little bit of ordered pair function stuff because I know a lot of people are more comfortable with the continuous graphs, but ordered pairs can be functions too. All right. Let's take a look at number 2 over here. And don't worry, I will share this document with you as well. So you'll have a copy of this. Okay, let's take a look at number 2. What do you think about this one? Just looking at the scatter plot, the blue dots, do you think it's a function? Okay? What makes you think it's a function? What are you looking for that you're not seeing? How do you know? Well, it does pass the vertical line test, right? Is basically what you're saying. Oh, wait a minute. What about here? Okay. Doesn't pass the vertical line test there, right? Have an input of -2. Like if I look at my drawing here, an input of -2, and sometimes it gives me a 0. That's the one right on the x-axis. And sometimes it gives me a -3. So that's not a function. So ordered pairs can also fail or pass the vertical line test, right? If you take a look at number 3 over here, okay, the trick, if you think about looking at these diagrams over here, trick is to look for repeated x values, okay? If I look at this over here, I don't see any x values that go to 2 different y's because all the x values are different, okay? So if I were to write this in a diagram, I get 1 goes to -2, I get -3 goes to -1, 1 goes to 0, 2 goes to 2, and 0 goes to 3. Right? So no problems there. I don't have a single input giving me 2 different outputs. So this one, yes, is a function. Right? And if we look at 4, okay, again, mentally try to draw vertical lines and see if you hit any dot twice. Okay? So if you take a look at this, all points pass the vertical line test. Right? Everybody good with that? So again, no matter where you draw vertical lines, you're only going to hit one.
Hello.
Good. Okay. All right. So 3 is not a function. Why do you say 3 is not a function, Jasmine? Oh, because 1 goes to 2 different things. Good for you. Okay. See what she noticed? She noticed this. Okay. So what I could have done was I could have done it like this. I could have said 1 goes to 2 and 1 goes to 0. Good for you, Jasmine. Thank you. Right. Okay, 2 outputs. Sorry, I've got one eye on the chat, but I'll pay closer attention. Okay. And Ariel, I'm not sure what your comment means. The outcome doesn't repeat. What do you mean? Okay, do you want to ask that question a little differently? Okay. It's okay for 2 different inputs to go to the same output, like here, where 2 and 3 both map to 2, but it's not okay for the same input to go to 2 different outputs. Okay. So basically, we're looking for 2 matching inputs like that. Okay. And that's how you're going to tell it's not a function. It's easier when you're looking at the points because you're just looking for vertical line tests. Okay. Again, please shout out if you see anything that doesn't look right. Okay. All righty. Then let's take a look at these. Okay. So these are more of the graphs you're familiar with from your algebra classes. Here we've got, what kind of a function is this? Anybody know what this is? Number 5. Anybody know what family of function that is? Yeah, it's a linear function, and it is a function, so I'm going to say yes, linear. Okay, and again, remember what domain is. Okay, so domain is all allowed inputs. Okay, and what does allowed mean? Okay, it means that those inputs don't give you undefined. They don't give you an undefined output. Right? So in a linear situation, you can type in any real number at all, okay? And you'll get a defined output. Okay, so that's one of the functions where normally, okay, if you're talking about a line and not a line segment like number 5, your domain would be all real numbers. But in this example, they're restricting the domain. Okay, can anybody let me know what they think the domain is? Yes, I will share my notes for sure. Okay, remember your domain are allowed X values. Guys, can you do me a favor, please, and mute your mics? Okay, please mute your microphones. Thank you. Okay, Kelly's saying it goes over to -3. I think this is -1, -2. Okay, good. Okay, so -2. And why did he put a curved bracket there? Okay, so he's saying the domain is -2, and it goes up to +2. All right. Anybody else besides Charlie want to explain why I'm using these weird mismatched brackets? Okay, anybody remember? You can just type in the chat. Why is there a curved parentheses on the left-hand side of this domain? Okay, it's like open circle, close circle. Okay, that's great, David. So basically what we're saying is the open circle here at -2 means I'm not including -2, right? So the domain can go all the way down to -2, but not include the -2. That's what the curved bracket means. And then going up, okay, the rightmost value that's in this graph is a +2. And because the circle is solid, I'm including the +2. Okay, so that's why I have the square bracket on that end. You can think of the square bracket as a handle you can grab onto. Okay, if you can grab onto the handle, then that endpoint is part of the domain. Okay, and you notice what we were doing when we were trying to look at it, we were looking just at the x-axis. One way that I tell students you can figure out domain, okay, is imagine you are riding along your graph, okay, and you're looking back at the x-axis, okay? If you can see the x-axis from your graph, then that value is in the domain. So if I'm over here, remember, I can't get to this point. So I can see everything just to the right of -2, all these values, and all the way up to +2, if I just keep looking at the x-axis. If you want to figure out range, you just have to change your perspective. And instead of looking at the x-axis, you look at the y-axis. Okay? Anybody want to try coming up with the range on this one? Again, remember, we're looking at y values now. Lowest y value to highest y value. Okay? Type in the chat if you think you have an answer for range. Okay, we're still on number 5. Anybody want to give it a shot? Okay, and again, we're looking at, okay, if you take a look here, we've got -1, -2. So our lowest y value is -2. And then coming on up here, what's our highest y value? +1. Tuyen, good for you. Okay. So basically, here, my lowest y value is -2. And again, that's looking at the y's like this. And the highest y value is +1. Okay, everybody see that? Anybody have any problems with that one? Okay, good. And I'm glad to see you're all comfortable with the interval notation, okay? We're going to be using that in this class, so I want to make sure everybody's good with it. Okay? All right, number 6. Let's start with the easy question. Is number 6 a function? Jasmine saying no. Anybody agree? Julieta says no. Tuyen, Ethan, Graciela, good for you. All right, this one fails the vertical line test in spades, right? As a matter of fact, there's really only 2 points where it passes, right here and right here. Everywhere else, this graph fails the vertical line test. Okay, so not a function, no. Okay, but if you consider it as a relation, okay, it also has a domain and a range, okay? If you think about it, the lowest x value on this graph is right here. The highest x value is right here. And those points are on the graph, okay? So they go from -3, +1, okay? Now again, it's not a function, it's a relation. Okay, so it's a relation. And then the range is the same way. You can kind of look at it from lowest y value, which is down here at -1, highest y value at +3. Okay, everybody good with that one? Okay, anybody any questions about that one? Let's take a quick look at number 7. Okay, do you think number 7's a function? Okay, again, it's not really clear what's going on here, but I think what they meant to draw was something that was a little less vertical here. So I would kind of say that yes, this is a function. All right, let's see if we can do the domain now. Okay, what's the lowest x value and the highest x value? And again, decide whether or not you're including the endpoints. You can type your answers in the chat. Okay, we're getting from Graciela, -2, +2. What do the rest of you think about that? Again, using my strategy, you're going to look up at the x-axis, see what's included. Okay, and why did she use the parentheses? Okay, Dustin and Jennifer came up with the same answer. Okay, again, because of the open circles, I can't actually reach -2 and I can't actually reach +2. Okay. For one like this, maybe the range is a little trickier. Okay, what you want to try to do is figure out what is the lowest y value you can reach and what is the highest y value you can reach. Again, imagine you're taking a trip along the curve and you're looking at the y value. So you want to see what's the lowest y value you reach and what's the highest. And again, think about it. Are you including these points? Okay. All right, we have some disagreement as to we're getting the same numbers, -4 and 0. But again, what do you think about square brackets or curved brackets? Are the black points that I drew on the graph on the curve? Okay, if they're on the curve, then you need square brackets because those are actual y values you can reach. Okay, everybody all right with this? Okay, cool. Let's see. Okay. I have a lot more like these, but basically, I want to kind of jump around a little because, again, you guys have this. I don't want to waste a lot of time going over stuff you obviously understand. Let's jump to something that's more of a function that you would have seen, say, in college algebra. Let's take a look at number 15. Okay, so I'm looking at number 15. Okay, and let's see if we can figure out what's the domain of that function. Now, what you want to realize about this graph is even though they didn't put it, it has arrowheads on it. Okay, so on these graphs, we're seeing arrowheads. Okay, and notice as you go up, those arms are going out. So what do you think about the domain of this function? Anybody have, okay, I'm getting infinity to infinity. Good, negative infinity to positive infinity. Right, because as these arms go up, they also go out. Okay, so let me just write that down. Okay, and somebody asked a question, I saw it go by in the chat, where will I post the notes? Okay, there's going to be in each module a section for a link to the video recording, and that's where I'll post the notes. So you have the recording and the notes together in the same place, okay? That way you just have to go to one spot to see what did we talk about during the last class. Okay. All right, folks, let's take a look at this same one, number 15, and see if we can come up with the range. Okay, remember, these are the y values. Okay, and again, what you want to recall is these points are actually on the graph. Okay, so what's the lowest y value and what's the highest y value, if there is one? Okay. Okay. So we're getting a couple of different answers. They don't vary as far as the values you're putting in, but they vary with the square brackets, smooth brackets, okay? The dots that I've drawn in black are actually on the graph, okay? And you can see those are at -6 on the y-axis. So I would put -6 for the square bracket because I can actually touch -6 on the graph, okay? As far as a y value. Because of the arrowheads, though, and they're heading up as far as they can go, there's no largest y value. So infinity goes there, positive infinity. And since that's not a number, we're going to put a curved bracket there. You can't ever touch infinity, okay? It's not a number. So that always gets a curved bracket. Now, what they're asking you next is they're saying, what is f of 2? Okay, so they're saying, when, what is what? See if you can explain that to me. What is that asking you? Okay, we're saying -4, okay, is one value. Okay, what that means is when x is 2, what is y? Okay, that's what it means. If I look at my graph, here's 2, and I follow it down till it touches the graph. And again, my graph isn't super accurate, so I agree it is probably -4. Okay, everybody comfortable with that? Okay, again, it's a little difficult to see whether it's -3 or -4, but there looks to be a little bit of space between the line and the grid point where -3 is. So I picked -4. Okay. Last one we're going to do here is this one. Okay, this one you might remember. If you look at 15, 15 is kind of like what you might remember as an even function, something that looks, I don't know, maybe like a 4th degree function, but it's got points instead of curves. Okay, what about number 60? Okay, this kind of looks like an odd degree function, right? It goes in from one side of my graph, and then it leaves from the opposite side, okay? So how about this one? What do you think the domain of this function is? Again, notice as this goes down, it's also moving to the left. As this goes up, it's also moving to the right. Okay, so Tuyen is saying negative to positive infinity. Anybody agree with her? Okay. Yes, because again, as this arm goes down, it's moving to the left. And again, you can go as far left as you want, as long as you go down far enough. This one's going up and to the right, so that's going to go up to positive infinity. Okay. In general, these two examples, 15 and 16, are kind of like even and odd polynomials. And you might remember from college algebra that polynomials all have a domain of all real numbers. Okay. Let's try range. Okay, now remember, range is y values. What do you think about that? Is there a lowest y value? Is there a highest y value? Okay, good job. Okay, this also has a range of negative to positive infinity. Okay, because the arrowheads are going in opposite directions. Okay. The next thing we want to try to do is evaluate the function when x is negative 2. What do you think the value of the function is when x is negative 2? Okay, that would be right here. Okay, and I do agree with everybody who's typing, that's a 0. Okay, so hopefully this was a kind of a refresher about domain and range and functions and that sort of thing. I guess the only other thing I wanted to share with you was about families of functions. Let me see if I can get to that. Parent functions, okay? How come it's 0? Okay, let me go back. Okay. Basically, what this notation means, and the reason why they put this question here, this notation is asking you when x is negative 2, what is y? Okay, so you go on x, which is your horizontal axis, till you find negative 2. And then you would go up or down to the function to see what the y value is. Well, the function happens to cross the x-axis right at negative 2. Okay, and on the x-axis, y is 0. Okay, so I'm going to just type that in the chat. Okay, on the x-axis, y is 0. Okay, is everybody all right with that? Again, please shout out your questions in the chat right away.
I think I become addicted.
I'm sorry. Want to try again? I can't hear you, Odie. You want to try it again?
I'm in class right now, Marisa.
Oh, I'm sorry. Okay.
I'm in class.
How's it going?
It's weird.
Yes, it is.
Because it's math, you know? I'd rather have it in person.
I think we'd all rather have it in person, Jennifer. No worries. We'll do the best we can. Okay. The main thing is make sure you ask if something is not clear. Okay. I'm super serious about that. I do not mind questions. I don't care if it's the evening. I don't care if it's the weekend. Ask when you get confused. Waiting will hardly ever make it better. Okay. So just ask. Okay. You guys are rocking this. So you are much better prepared than a lot of brief calculus classes. So that's cool. Okay. Let's take a quick look at this. Okay. And essentially what, hopefully this is large enough for you to see. Okay. Can everybody see that? Is that big enough? Okay. So basically, can people like remind themselves what type of functions these are just from looking at the symbolic rule? Okay, we'll just do a couple of them. I don't want to spend a lot of time with them. Okay. How about number 1? What type of function is it? What family of functions does it come from? Anybody know what it's called? Okay. All right, you see that exponent? Okay, we're getting a couple of values. Some people are saying linear, some people are saying exponential, which is going to spark some good discussions. Okay, I'm going to write some examples over here. Okay, so how about f of x equals x minus 1? Okay, that one is linear. Okay, how do I know it's linear? Because x has an exponent of 1. Even though you don't see it, there's a 1 implied when you don't see the exponent. Okay, so basically, that's what you've got here. You've got a linear function. That means the highest power on your variable is a 1. Okay, how about this? Okay, there your x is up in the exponent, so that's exponential. Okay, that means this guy must be something else. Okay, because it's not linear, because there's a 2 is the exponent, and it's not exponential because the x isn't up in the exponent. So what do you think? Anybody got any other guesses what it might be? Polynomial, good for you. Okay, it's a polynomial in general. Okay, and because it's degree 2, it's quadratic. Okay, so polynomial quadratic. All right, how about number 2? What do those weird vertical bars mean? Anybody remember those? What type of function is that? Absolute something? Absolute value, good. Okay, these functions, absolute value functions, are used for tolerances. In other words, say you're building a house, and let's say you're allowed to be off in your measurements by 1/4 of an inch, either too large or too small. Okay, so it doesn't matter which direction, okay, but within 1/4 of an inch tolerance. Okay, that's what absolute values are used for. Okay, how about number 3? What kind of a function is that? Good, Tian, square root. Okay, how do you know the root is, it's a square root? Okay, how about a function that looks like this? What kind of function would this be? Anybody have any idea what j of x is that I wrote over here? That's a cube root, right? So basically, that little 3 is called an index, okay? And if it's not there, like it is in h of x, okay, you can see that it's implied to be a 2. Part of what I'm pointing out is, what are some of the assumptions that are made in algebra, okay? It's really like learning a foreign language, okay? And like many foreign languages, there are assumptions in the way they use terms, okay? So I'm trying to make sure those are clear to you. How about g of x, this one, number 4? What kind of function is that? It's cubic, okay? Its general family is polynomial, and its specific family branch is cubic, okay? So the quadratic function in number 1 is part of the polynomial family. The cubic function in number 4 is part of the polynomial family, but they're from different branches. So they have a resemblance to each other, just like branches of a family, but they don't look exactly alike, okay? Just like you may not exactly look like your aunt or your uncle, okay? But you look a little bit similar, yeah? Okay, same idea. We'll get to the graphs in a minute. How about this one, number 5? Anybody remember what the functions are called with x's in the denominator? What are those called? Okay, it looks like a reciprocal, okay, because it's upside down, but there's a family name for these functions. Anybody remember this? Rational. okay, rational functions, okay? And again, you have your independent variable, which is usually x in the denominator. Okay, that's kind of how you recognize that one. Okay, so again, how did we decide what these were? Okay, so again, with number one, we're looking for 2 as our exponent, the highest exponent on x. That means I'm quadratic. Over here with number 4, 3, the highest exponent on x, I'm cubic. Okay, the vertical bars say absolute value as long as x is inside there. The square root, okay, is the square root radical sign with no index, and the x is inside there, okay? All right, and then rationals are the ones with the x in the denominator. Here's another absolute value. Okay, everybody good with that? Now, of all of these functions, the ones where you have to worry about your domain not being all real numbers, it's going to be this one and this one. Okay, so these are the ones where you've got restrictions on the domain. Okay, so domain is not all real numbers. Okay, the square root, okay, the domain is not all real numbers because there's going to be part of the domain, part of the x values that you're not going to be able to put into the function because they're going to give you imaginary numbers. Remember, you can't take the square root of a negative number. Okay, that's not true of a cube root. Okay, cube roots can have a domain of all real numbers because you can put in negatives and get out negatives. Okay, but not true for square roots or even roots. With the rational function, those are the guys that have the vertical asymptotes that shoot off to infinity. Okay, where the graph shoots off to infinity, and they have holes sometimes. Okay, so there are undefined spots in those functions, just like your square root has a whole range of undefined values. Okay? So let's just take a quick look at the basic graphs. Okay, so now what they're talking about is look at the actual symbolic rule for this. Okay, here I have my x in a denominator. So what kind of function do you think number 7 is? Okay, what kind of function? Anybody have any ideas? Good, rational. Okay, and they want to know the basic graph for that kind of function. Okay, so I'm not drawing the graph h of x. Okay, here's the basic graph for that kind of function, right? With a vertical asymptote at 0. Okay, so it's important to know what shape these graphs have. Okay, this one, number 8, what kind of a graph, what kind of a function do you think this one is? Number 8. Anybody have any ideas for number 8? Okay, and what do those look like? Well, let me draw those. Okay, and again, this is not the graph of g of x, but the base graph, okay, where it's y equals the square root. Okay, just like this is y equals 1. Okay, everybody get it? Okay, h of x is quadratic. Okay, the base graph for a quadratic is a parabola, which looks like this. Again, I don't have enough room to draw it accurately. And you can tell what they've done here is they've applied some transformations. Okay, so the actual graph of h of x would look different from this. It would be flipped across the x-axis and it would be raised up 1 because of the transformations. Okay, this one is an absolute value. Okay, and that graph is the one that looks like a V. Okay, the base graph. Okay, everybody comfortable with these? Okay, part of what I'll put up in the course as a review for you is a sheet that just shows you all the different types of functions. their graphs and their basic equations. Like again, this would be y equals x squared. This would be y equals the absolute value of x. Okay. So again, it's important to have some ideas of what your base functions look like. Okay. If I were to write y equals x cubed, that function would look like this. Okay. So again, part of what you want to be able to do in order to do calculus accurately and in a reasonable amount of time is recognize what kind of function you're dealing with, because how you're going to do calculus on it is going to depend on what type of family it's from. Okay, so the rules for doing calculus vary a little bit depending on the family of function. That's kind of why we went through all of this. Okay, and also we'll see when we start talking about limits in this class that there are some restrictions that you have to worry about depending on where you might have holes in your domain. Okay, calculus doesn't work really well when you've got things that are undefined. So that's part of the reason we spend some time going over domain and range. Okay? The only other thing you really need to pay attention to is kind of like rules of exponents. Okay, so I'm going to see if I can share that with you. Let's see if I can share more content. And let's see. Okay, I am not seeing this. So share text. Okay. Okay, let's see. I'm sharing 3 applications. Can you see a PowerPoint? Can everybody see a PowerPoint? Okay. Let me just bring up one slide in this PowerPoint that I want to share. Okay, so everybody's seeing rules of exponent review. We're good with that? Okay, so again, a lot of these rules of exponents are pretty basic. You might remember this one. So if I have x squared times x cubed, I'm going to add the 2 and the 3 to get x to the 5th. If I have x cubed divided by x squared, I'm going to do 3 minus 2 and get x to the 1st. Here's where you're raising a power to a power. You multiply the exponents. So everybody's good with those. The ones that are the most important when you're doing calculus is number 4. Okay, when you have just one x to some power in the denominator, you can rewrite that as x to the minus n, right? Because negative exponents don't give you negative numbers, they give you fractions. Okay, so this is a very important power of exponents. So is number 5. You might remember from college algebra that if you have the nth root of x to the n, you can rewrite that with a fractional exponent. The root m goes in the denominator of the fraction, and the power n goes in the numerator of the fraction. Okay? Number 4 and number 5 are super important to simplifying expressions algebraically before you try to do calculus on them. Okay? So I kind of tried to touch on a few of the things that are going to be important from college algebra going forward. Okay, recognizing functions, recognizing domains of functions, families of functions, and these few rules of exponents. Okay, here's another one that's important. Okay, besides 4 and 5, look at number 8. You might remember this as anything to the 0 power is 1. Okay. So these 3 rules of exponents are going to be important going forward. Okay? So let me stop at this point and ask any questions about the review. All right, and I will make sure you have all of the information you need in your Canvas course. Okay, we're good with that? Okay. So you guys should now be, I'm going to stop sharing my screen. And I'll go back to the meeting with you guys. And basically, what I would tell you is you are in good shape to read the material for section 1.1. Okay, look at the videos for 1.1 and actually start on the homework. Okay, there's nothing new that we learned today. This is all pretty much a review of college algebra. The stuff we're going to be doing Thursday is also a review of some topics in college algebra, but I can tell you they're important. So please do me a favor and don't blow off the session. Actually come and ask your questions. Okay, we want to make sure that everybody is starting roughly on the same footing. Okay, because the problem that most students have in brief calculus isn't with calculus. Okay, it's what they do or don't remember from algebra. Okay, so if everybody is okay at this point, I'm going to stop recording. Okay, and I will make sure